one of the things I want to kind of show is a little bit behind the scenes look of how some of these modern small companies can create products really fast using all the various open source software and hardware technologies that are out there. So I'm Thingham. We make these smart LEDs. Here's one right here. It's a LED that's got a small computer on the back that's about 8 times faster than Apple II, but costs like 60 cents. And you can load it up with a color pattern, and it'll keep playing that pattern as long as power is applied. You can also hook them up to an Arduino. One of the things that we've worked very hard is to make it so that it plugs directly into Arduino without any soldering or wiring. You can just plug in and go. And these things have been used in Lady Gaga costumes, and our little USB programmer for these is used in the Stanford Linear Accelerator for some FPGA programmer thing. I don't even know what it does exactly. Thingham also creates sort of sketches of how computational devices can be used in kind of mundane objects. The 2 examples here is a smart wine rack. It's a wine rack that knows what wine that's in it and can recommend the wine for you. It'll light up the bottles depending on what search criteria that you've given it on a little touchpad. The thing on the right is a sort of an ambiently aware drawer pull for a cabinet or something. So as you get close to it, it kind of glows magically, sort of jewelry for your house. We also have been doing for the last 6 years or so this conference called SketchNet Hardware. This is mostly my business partner's, Mike Kuniowski's baby. And it is a small conference trying to get together all these people that are working on these toolkits for enabling the sketching of ideas, almost like the Lego of electronics, and Arduino is kind of the best example of that. Now, some of the things that I personally do, I write for Make every once in a while. I wrote the book on Hacking Roomba, called Hacking Roomba. I've created a bunch of sort of add-ons for Arduino that's independent of Thingham. There's the screw shield. There's a bunch of lets you wire up things easier to the Arduino. The WeChuck adapter lets you hook up your Wii Nunchuck to your Arduino pretty easily. I co-founded a hackerspace in LA a couple years ago called CrashSpace, and I work with artists around LA and Southern California to do crazy art installations. The red thing is a huge 100-foot-long pneumatic tube system in a children's museum in San Diego. The kind of purpley thing on the bottom is this 20-foot-tall plexiglass and LED sculpture in downtown LA. So one of the reasons that I like to use open source is that it's kind of the same thing for the scientific community. You get this free exchange of ideas. You can use other people's cleverness, so you don't have to be as clever. But also, you can save a lot of time. So there's a lot of stuff that's already been invented. You don't have to do much of the work yourself. The design process that we go through is something like this. You might think it's kind of a linear sort of set of progression. Turns out it kind of all swishes around. As you find out things in one area, you end up having to revisit things you thought you had already decided. So as an example, I'm going to use a sneak preview of a product that we hopefully will have up on Kickstarter within about a week or 2. We're hoping to have it for Maker Faire, but I don't think we're going to make it. And this is taking the idea of a Blinkum and just kind of jamming a USB port onto it. It's one of the things that we really liked about the Blinkum is that it enables people who don't know how to work with multicolored LEDs to work with them without knowing anything about color mixing, whatever. Like the Blinkum embeds a lot of that color theory knowledge into it. And unfortunately, you still need to know how to use an Arduino. And for some people, the bare circuit board of an Arduino is a little bit off-putting. Even the bare circuit board of a Blinkum is a little bit off-putting. So let's wrap that all in a nicely designed enclosure, put a USB port on it, and now you can have this sort of ambient, glanceable little bit of color on any computer that has a USB jack. So the first thing we did was look at a bunch of different other examples of little USB gizmos. These are all examples of open source USB projects. Looked at closed source versions as well, but they have a different kind of a scale of economy that we can't match because they build 10 or 100,000 of things. We're looking to build like maybe 10,000 to start. And then we did a whole bunch of different designs using a whole bunch of different chip formats, a whole bunch of different layouts to see what would look and work best. And because of the quick turn PCB factories that are out there, we can get kind of one or all of them made and try them all out. And one of the coolest things is that there's this plugin for SketchUp that lets you get dimensionally accurate 3D models of your circuit that you've built. So even while you're waiting for the PCB to be physically made, you can still kind of work with the physical representation of it, because now we can talk with our industrial designer who has been working with enclosure design, and we can meld what the PCB physical form is like with the enclosure and see if it kind of makes sense. We can save a lot of time because we can kind of do all this before we even have physical objects in our hands. But then, once we do have physical objects, which is kind of like a week later, we can 3D print those models out on a 3D printer like a MakerBot and just start trying things out, seeing what works, seeing what doesn't. For this, it was important that the enclosure be translucent enough so the LED can shine through. And we're also working with light piping to try to get the LED, get the light to come out in a very particular way. It's hard to capture taking pictures of LEDs with a camera, it turns out. So the other side of things is the firmware side. There is a whole pipeline of code you have to worry about for any USB gadget. There's, on the kind of the endpoints, there's the firmware that's specific to your application. On the host side, there's the application code that's specific for your task. And if you want to be cross-platform, you have to do it for all the different OSs. It'd be nice if we could make most of that go away. And it turns out with a lot of the open source stuff that's pretty much true. For the chip libraries, there's all these different things, like for AVR chips, there's Arduino. And the first version of this was prototyped on an Arduino. That was like the first day. And then there's, for other chips, there's also other options as well. Same thing with the actual USB firmware that talks to the USB port and does the USB protocol. It used to be you had to have a particular type of chip to do USB, but now there are these software versions that basically does bit banging of USB on a bunch of different types of normal microprocessors or normal microcontrollers that don't have proper USB hardware. So you can kind of use much cheaper, smaller chips than you normally would be able to. And there is, on the application side, there's all these open source tools like processing to let you write GUIs and things like that. Unfortunately, this area, while all the other stuff is really good, this still is a little bit not quite fully baked. If you want to have a application that feels right for the OS, you know, that feels like a Windows app, feels like a Mac OS X app, you have to pretty much write it with native stuff. And so this is kind of the hardest part right now for us, just because you have to have a lot of different expertise. You can't do write once, run anywhere. This doesn't look right. I mean, you can get going really quickly with it, but if you want to deploy really good stuff, I think native's the way to go. So that's what's difficult, is the last mile, screen to keyboard. The other hard part is actually getting the enclosures made in a way that works. Like, there's a difference in how as other people were mentioning, there's a difference in how 3D printing works for objects versus actual injection molding of something. Not just in the dimensional accuracies, but also just the materials. You know, the natural ABS versus whatever, like Lustran or whatever injection molded plastic you might use. But the upside is that you can get a functional prototype in 2 weeks. You're able to explore multiple designs on multiple chip architectures in the same amount of time, and you can be manufacturable within a month. And so that's pretty much, that's the process that we went through with this. It was a pretty well-defined problem that had a sort of a minimal feature set, but you can kind of take these techniques for kind of other things too. And finally, once you've done all this, publish it. Tell everyone. There's all these different sites that people have been talking about, even your blog. One of the nice things about publishing is it lets you give back the things that aren't necessarily the proprietary parts of your thing, but also you get the makers on your side. They're the early adopters. They're the recommenders to everyone else. So they're the good ones to have on your pod. And that's me.